Alright, so we're going to be talking about antiderivatives and indefinite integration. So an antiderivative is exactly what it sounds like. It's the opposite of a derivative. So that means going backwards. Yay! So suppose you need a function f whose derivative is f of x equals 3x squared. So what would you guess f, the big F of x would be? So in other words, when I take whatever f is, when I take its derivative, that's what I want to get, right? So that means like I would need to get a square, it comes from a cubed, right? And then when you bring it down, take one off, I get 3x squared. So, but what if it had like like a plus 2? Would that work? Yeah, that would work. Or how about like a plus 5? That would work too. What about a plus 5x? No, that wouldn't work. So in general, we can say that f of x is any x cubed plus any constant. Okay, f is an antiderivative of f. Can you list some other antiderivatives of f? We just listed some. So any x cubed that has like plus a constant. Okay? Representation of antiderivatives. So if f is an antiderivative of little f on interval I, then g is an antiderivative of f on the interval I if and only if g is of the form g of x equals f of x plus c. In other words, like there are an infinite number of antiderivatives because of that constant thing that we just talked about up there, that you can do the derivative of constant and it just goes away. So when you're going backwards, when you know the derivative and you're going backwards, don't forget your plus c. Okay, because there are an infinite number of representations. So find the general solution of the differential equation y prime equals 2. Okay, well so find a solution of a differential equation just means give the original. Or not get, let's change that. Let's say find if f prime of x is given. So in other words, I just want to know what y is. Well, y would just be 2x. And then don't forget plus c. That is the general equation, general solution. This would be the plus c part. If it says the particular, excuse me, if it gives the particular solution, then you'd have to solve for the constant given a point. And we'll do that. All right, when solving a differential equation of the form dy dx, it's convenient to write it in the equivalent form of dy equals f of x dx. These are called the differentials. And what it's saying is the differential of y is equal to the original function times the differential of x. The operation of finding all solutions of this equation is called antidifferentiation or indefinite integration and is denoted by the integral sign, which is like a sum symbol. It's like a S. The general solution is denoted by y equals the antiderivative of f of x dx equals f of x plus c. So this right here is the integrand and the x indicates the integral of integration. Sorry, not the integral, the variable. Let's see. The variable of integration. Makes sense. See, like the dx is saying that that's the variable on this side, and that c is the constant of integration. All right. The expression, this, is read as the antiderivative of f with respect to x. So the differential dx serves to identify x as the variable of integration. There is a basic list of integration rules, and on page 2, it's not 278 now, it is page 286. I would highly recommend that you memorize those. They're really most of the ones that you know, and we're going to be practicing them, but they're like the backwards of it. Okay, so I highly recommend that you memorize those. Describe the antiderivatives of 3x. Okay, well, let's first write that in mathematical symbols. So this would be the antiderivative of 3x dx. All right, so what this means is just what is the antiderivative of 3x? Well, constants don't actually change anything. Just like in derivatives, constants don't change anything. In antiderivatives, they don't change anything. They just are a constant multiplier. So I could write this as 3 and then the antiderivative of x dx. All right? Well, if you look at the antiderivative of x and you think about it, well, this is, if you look at the rules on page 286, this is the antiderivative of x to the n dx, okay? Which is x to the n plus 1 over n plus 1 plus c. All right, now this should make sense to you because if you go this way, bring it down, the n plus 1's would cancel, and then take 1 off and you just get n. See? So if you go backwards, you add 1 up and divide. Instead of bring it down, subtract 1 off and multiply, you add 1 up and divide. All right? Okay, so this would be 3, and then x to the 1 plus 1 over 1 plus 1 plus c. Or in other words, 3 halves x squared plus c. All right. All right, the next one. So the original integral, rewrite it to be able to use the power rule. So that would be x to the negative 3 dx. Then integrate it. So then add 1. So that would be x to the negative 2. And divide by that new number. So negative 2 plus c. And then simplify. So that would be negative 1 over 2x squared plus c. The next one would be the antiderivative, x to the 1/2 dx. Then you add 1, so that would be 3 halves, and then divide by 3 halves plus c. Add 1, which would be 3 halves. So then I would get 2/3 x to the 3 halves, which is fine to leave it as x to the 3 halves, plus c. All right, the next one, if you want to rewrite it, you do 2 antiderivative sine x dx. Okay, now it goes sc, negative s, negative c. So the antiderivative, this is derivatives going this way. So the antiderivative would go this way. So I would get negative 2 cosine of x plus c, which would, that's it. That is simplified. All right, now the next one is 3 antiderivative of 1 over x dx. Now how come I didn't write this as x to the negative 1? Let's do that up here. X to the negative 1. And then you add 1 and divide by it. You would get x to the 0 over 0, which does not exist. That is not an answer. Does not exist is not an answer for antiderivatives. You're trying to find the function, not a value. So does not exist is not an answer. All right, so if you can't do that, then this must be the derivative of something else. Think about it, and you realize that this is the derivative of the natural log, right? The natural log of x is 1 over x for the derivative, so this would be 3 natural log of x plus c. Now you have to put absolute values around that when you go backwards, because this could have been negative, but this can't. So you have to have absolute values going that way. If you start with natural log, it's already understood that it can't be negative. So that's why you don't have to put them. But going this way, it originated from something that could have been negative, so we have to fix it. And that's it. There's nothing else to be done for that, so you just write it again. Okay. Remember, you can check your answer by differentiating and seeing if you get the nth grade, right? You can, like, take the derivative of this. What's the derivative of natural log? 1 over x. Okay? So, all right, so integrate this. This is the antiderivative of 1 dx. If you don't see anything there, it's a 1. So, this would be like 1 x to the 0. Okay? Or just a constant. So, it must have come from, remember this is like the derivative of, so it must have come from an x, right? Because then the derivative of x is 1. All right, this one, well, you can split it up and say that's the derivative of x dx plus the antiderivative of 2 dx. Antiderivative of x is 1/2 x squared, and the antiderivative of 2 is 2x plus c. Remember, the great thing about watching a video is that you can pause it if you would like to, like right here, and then try it, and then see if you got what I got. Okay, because I understand that sometimes I go a little fast, but pause it if I'm going too fast. All right, this one is the antiderivative of 3x to the 4th dx minus 5 antiderivative of x squared dx plus the antiderivative of x dx. Eventually, we're not going to write all this. We'll just do it right where it is. All right, so you're going to add 1 and divide by that new number, so that'd be 5. So 3/5 x to the 5th. And you don't have to write plus c each time. You can just write one single plus c, because a constant plus a constant plus a constant is still just a constant. So c1, so constant 1 plus constant 2 plus constant 3 is just one giant conglomerate constant. All right, and then minus, now add 1, that would be 3, so 5/3 x cubed. Add 1, that would be 2, so plus 1/2 x squared plus c. All right, so hopefully you're getting the hang of the power rule and sine and cosine and log, well, natural log. Please make sure you do some homework and practice it. You need to be pretty good at it, as usual. Okay, so now this is interesting because this is nothing that I know, but if you simplify, all right, x plus 1 over root x. So I'm just going to like put a star here so that when I'm done with my scratch work, I can come back and just say it equals that. So, all right, so this is x plus 1 over x to the 1/2. Now split that up. That's x over x to the 1/2 plus 1 over x to the 1/2, which is 1 minus a half is a half, plus x to the negative 1/2. So then now that equals the antiderivative of x to the 1/2 plus x to the negative 1/2 dx. So now I add 1, that would be 3/2, so 2/3, because you divide by 3/2, so that would be flip it. And then you get x to the 3/2. All right, now add 1, and you get positive 1/2, so plus 2 x to the 1/2. Yep. Plus c. All right. The next one, we got to think of Now, you can't just do the antiderivative of sine over the antiderivative of cosine, all right, because there's a quotient rule to get derivatives. Therefore, there must be some kind of rule to get antiderivatives. There is no quotient rule for antiderivatives, okay? Besides that list, there's not really a whole lot you can do for antiderivatives, but be clever. Clever tricks is all there is. All right. So let's see. So sine over cosine, cosine. Well, that's sine over cosine times 1 over cosine. Sine over cosine is tangent, and that's secant. Oh, and we know a derivative for that, right? The derivative of secant is secant x tangent x, yeah? So, yeah, so the antiderivative of secant, this is of secant x tangent x dx is secant x plus c. Alright, so you've already seen that the antiderivative of f of x dx has many solutions, each differing by a constant. This means that the graphs of any two antiderivatives are what? Well, they'd be like, kind of parallel would be the would be the idea behind it, because they only differ by a constant. So that would be like vertical translations. I don't know if you'd call that parallel. This is what I'm putting in quotes. They're really like just vertical translations of each other. In many applications of integrations, you are given enough information to determine a particular solution. To do this, you need only know the value of y equals f of x for one value of x called the initial condition. It doesn't have to be actually initial, like t doesn't have to equal 0. It just means one other condition. All right, so let's do the antiderivative of this. So first I'm going to do the antiderivative of 3x squared dx minus the antiderivative of 1 dx, right? So the antiderivative of x squared is add 1, that would give you 3 divided by 3. And then add 1, that would give you actually next to the first divided by 1. Alright, so now I have f of x equals x cubed minus x plus c. But then they give me this condition right here. Well, that would mean that 4 equals 2 cubed minus 2 plus c. Or in other words, 4 equals 8 minus 2 plus c, 8, 7, 6, and then negative 2 equals c. So my particular solution would actually be f of x equals x cubed minus x minus 2. All right, find the general solution and the particular solution that satisfies. So first the one with plus c. So general solution is plus c. Particular solution is like c equals a number. This satisfies the condition. Okay, so the antiderivative of e to the x dx. All right, well, the derivative of e to the x is e to the x, so we're just going to get e to the x plus c. All right, so then 3 has to equal e to the 0 plus c. So then that's 3 equals 1 plus c. So 2 equals c. So my particular solution would be f of x equals e to the x plus 2. All right, so the ball is thrown upward with an initial velocity of 64 feet per second. Okay, that means that like v of 0, that's what initial velocity means, is like time is 0. And it's thrown upward, so 64. From an initial height of 80 feet. All right, well, generally the height function is called s for some reason. Okay, so that's s of 0 equals 80. Find a position function given the height as a function of time. All right, so I guess I need to also tell you that and acceleration is constant, negative 32 feet per second squared. All right, so what this is saying is a of t is negative 32. Okay, well, if I want to do, now if you think about it, it goes s, v, a. That way. The derivative of s is v, the derivative of v is a. So this would be a derivative. So this would be antiderivative. All right, so the antiderivative, so v of t would be the antiderivative of negative 32 dt. Because we're talking about time here, that's like x here. All right, well that would be negative 32t plus c. All right, well, I need to figure that out, but they gave me an initial, so v of 0, so 64 equals negative 32 times 0 plus c, so then 64 is c. All right, so v of t is negative 32t plus 64. All right, but then now s of t is just the antiderivative of v of t dt. All right, so that is the antiderivative of negative 32t plus 64 dt. Well, add 1 divided by 2, that would be t squared divided by 2 would be negative 16 t squared plus add 1 would just be t divided by 1, so 64t plus c. And then that would be the general one. And then we know that it starts at a height of 80 feet. So 80 equals negative 16t squared plus 64t, oops, not t, it would be negative 16 0 squared, 64 0 plus c, so c is 80. So then s of t equals negative 16t squared plus 64t plus 80. That is the particular equation. And this is interesting because if we had done this with like 9.8, then you would have gotten 4.95. So that's where that formula comes from that we just use in physics so often, is just that negative 4.95 v sub 0 plus h sub 0. That's it. It's just derived from doing antiderivatives of acceleration is velocity, and the antiderivative of velocity is height for free fall. Okay, and then when does the ball hit the ground? So ball hit the ground means that, so when, we want t equals what? When s of t equals 0, right? Hits the ground. So negative 16t squared plus 64t plus 80 equals 0. And then I think this is all divisible by 16. So we get t squared, and then 64 divided by 16 is what? 4? Yeah. So minus 4t, and 80 divided by 16 is 5. So minus 5 equals 0. So that's going to be t minus 5, p plus 1. So then t equals 5 or negative 1, but that's nonsense. So it hits after 5 seconds. And of course you can use the quadratic formula if it was not factorable. Alright, so that's the end of 5.1. Please make sure that you do your 5.1 homework before you move on to 5.2. It's really important that you are good with antiderivatives. In fact, I care more about 5.1 than I do 5.2 because this is summations. Thank you.